Have you ever pondered the possibility of a second Earth existing somewhere in the vast universe? It's a tantalizing concept, isn't it? This isn't science fiction, but a genuine scientific pursuit. We're talking about the search for exoplanets, or planets that orbit stars outside our solar system. Exoplanets are more than just distant specks of light. They're potential homes, potential Earths. But what makes a planet a suitable candidate for life as we know it? Well, there are three crucial criteria that scientists look for. First, the planet needs to be the right size. If it's too small, it won't be able to hold onto an atmosphere. Too large, and it's likely to be a gas giant, like Jupiter, rather than a rocky world like ours. Second, the planet needs to be at just the right distance from its star. This is often called the Goldilocks zone, where conditions are not too hot, not too cold, but just right for liquid water to exist on the surface. Last but certainly not least, the planet needs to have water, the elixir of life. Water is a key ingredient for life as we know it. Without it, the chances of finding life dramatically plummet. One of the most promising candidates meeting these criteria is a planet called Kepler 186f. Discovered in 2014, it's the first Earth-sized planet found residing comfortably in the habitable zone of its star. It's a tantalizing hint that there might be other Earth-like worlds out there. Imagine the possibilities if such a planet exists, teeming with life, perhaps even intelligent beings. What would they look like? How would they think? What could we learn from them, and what could they learn from us? This is more than just a journey of discovery. It's a journey of reflection, forcing us to look at our own planet and our place in the universe. As we gaze out into the cosmos in search of a second Earth, we might just find a deeper understanding of our own. The quest for a second Earth is not just science fiction, it's a real scientific endeavor. Imagine a world like ours, a planet with similar conditions, capable of sustaining life as we know it. This is the dream that propels scientists to scour the cosmos, hunting for what we call exoplanets, or planets outside our solar system. So how do we find these elusive exoplanets? One of the main methods is called the transit method. Picture this, a planet moving in front of its star, causing a tiny dip in the star's brightness. This minuscule flicker, caught by our telescopes, is a telltale sign of an exoplanet. It's like spotting a mosquito flying across a distant spotlight. It's not easy, but with the right tools and a lot of patience, it's possible. However, this method has its limitations. It requires the planet's orbit to be edge-on to our line of sight, which is not always the case. Another method we use is Doppler spectroscopy, sometimes referred to as the radial velocity method. This technique observes the subtle shift in starlight caused by the gravitational tug of an orbiting planet. As the planet orbits, it pulls its star towards and away from us, causing the starlight to shift in color, much like a siren changing pitch as it passes by. This method can reveal a planet's mass and orbit, but it struggles to detect small planets that cause only minor shifts in their star's position. Each method has its strengths and weaknesses. Sometimes they're used in conjunction, creating a more complete picture of a potential Earth 2.0. But there are still many challenges. Many exoplanets are too far away, too dim, or orbit stars that are too bright for our current technology to detect. Despite these hurdles, our search continues. The search for Earth 2.0 is a challenging task, but one that could potentially revolutionize our understanding of life in the universe. With every new discovery, we inch closer to answering one of humanity's oldest questions. Are we alone in the cosmos? Suppose we did find a second Earth, what would life on such a planet look like? Well, that's a fascinating question. Let's delve into it. First and foremost, life as we know it is shaped by a multitude of factors. Environmental conditions play a substantial role. Think about the climate and weather patterns on Earth, the mix of gases in the atmosphere, the presence of water. Each of these factors influences what types of organisms can thrive. Now let's imagine Earth 2.0. If it's similar to our home planet, it may have oceans, mountains, and diverse climates. It might have an atmosphere composed of nitrogen, oxygen, and traces of other gases. If that's the case, life there could look somewhat familiar. We might find forests of trees, fields of grass, and a variety of animal-like life forms. But what if Earth 2.0 is different? What if it's a little colder, a little hotter, or if its atmosphere contains different gases? This is where things get really interesting. Life on Earth 2.0 could be entirely alien to us. We might find organisms that have evolved to survive in ways we can hardly imagine. They might use silicon instead of carbon to build their bodies, or breathe sulfur instead of oxygen. Then there's the matter of available resources. On Earth, life has adapted to utilize virtually every resource available, from sunlight to iron deep in the ground. On Earth 2.0, the available resources could be vastly different, leading to life forms that have evolved in completely unique ways. All these possibilities lead us to one conclusion. Life on a second Earth could be unimaginably different. It could be similar to what we know, or it could be so alien that we struggle to even recognize it as life. But that's the beauty of it. Discovering life on another planet would not only expand our knowledge of the universe, it would also push the boundaries of our understanding of what it means to be alive. The discovery of a second Earth would undoubtedly have profound implications. Picture this: a planet that mirrors ours, tucked away somewhere in the cosmos. This isn't just a fascinating thought, it's a perspective-altering concept that would change our understanding of the universe and our place in it. From a scientific standpoint, such a discovery would be revolutionary. It would not only validate our theories about the existence of habitable planets beyond our solar system, but also open doors to a plethora of new research possibilities. Imagine the leaps in knowledge we could make by studying another Earth-like planet. We could learn about its climate, its geological history, and perhaps even its life forms. The potential for scientific advancement is truly staggering. Philosophically, the existence of a second Earth would challenge our most fundamental beliefs. The discovery of life elsewhere in the universe, for instance, would cause us to reconsider our notions of life's rarity and uniqueness. We would have to grapple with the idea that we are not alone in the universe, that we are part of a larger cosmic community. This could lead to a shift in how we perceive ourselves and our responsibilities as a species. On a societal level, the impact would be equally profound. The promise of a second Earth could spark a new era of space exploration, potentially igniting a race to reach this new world. This could result in unprecedented technological advancements, as nations and private enterprises strive to develop the means for interstellar travel. However, we must also consider the ethical implications. If we find life on another planet, how do we approach it? What are our responsibilities to these potentially new life forms? These are complex questions that we must begin to contemplate. The discovery of a second Earth could be the most significant event in human history, reshaping our view of the universe and our place in it. As we gaze up at the stars, we can't help but wonder, what if there's another Earth out there? And more importantly, what would it mean for us? Or, as we continue our cosmic journey, what does the future hold for the exploration of a second Earth? Our quest to find and explore Earth 2.0 is just beginning. The next few decades promise an exciting array of missions and technologies that could revolutionize our understanding of the universe and our place within it. One such mission is the launch of the James Webb Space Telescope. This marvel of human ingenuity is set to be the most powerful space telescope ever built. It will peer deeper into space than ever before, revealing the secrets of the earliest galaxies and perhaps the telltale signs of life on distant exoplanets. But the James Webb Space Telescope is just the tip of the iceberg. Future missions, some already in the planning stages, aim to send spacecraft to exoplanets within our cosmic neighborhood. These missions could provide us with our first close-up look at a second Earth, revealing details about its atmosphere, climate, and potentially signs of life. In addition to these missions, new technologies are being developed that could aid in our exploration of Earth 2.0. For instance, advanced propulsion systems could shorten the journey to distant exoplanets, while new robotic and artificial intelligence technologies could help us study these worlds in unprecedented detail. And then there's the possibility of interstellar travel. Though it may sound like science fiction, scientists and engineers are already working on concepts for spacecraft that could travel to other star systems, potentially bringing us face to face with a second Earth. The future of Earth 2.0 exploration is not only about finding new worlds, but also about learning more about ourselves. By studying other Earth-like planets, we can gain a better understanding of our own planet and the life it supports. The future holds exciting possibilities in the quest for a second Earth, a quest that could redefine our understanding of life, the universe, and ourselves.